Okay, so now we'll do some trigonometry, which trigonometry is kind of fundamental in engineering, especially in statics and mechanics and a lot of engineering, but you absolutely need it. And I think that it's also useful to practice for the FE exam because it comes up in the math section as well, but you'll definitely need trig stuff for other engineering parts. Okay, so let's start here. Trigonometry in engineering is fundamentally about triangles, especially in the unit circle, where sine theta, cosine theta, and tangent theta represent portions of a triangle, a right triangle, inscribed in a circle of radius 1. You will use trig identities to simplify expressions, solve equations, and apply them to vector components, or angles. So here, one thing to note is that our x-coordinate and our y-coordinate are cosine theta and sine theta. So here we have a point xy, which is cosine theta and sine theta. Okay? So now we'll start some problems. Starting with the first one, we're going to simplify sine squared x plus cosine squared x over secant x. And so the way that we can do that is we have sine squared x plus cosine squared x over secant x. And we know that cosine squared plus sine squared is really equal to 1, because if we look at the triangle again up here, and we use Pythagorean's theorem, right? Pythagorean's theorem is that if this is a and b, a squared, and if this is c, a squared plus b squared equals c squared. So we're going to have cosine squared theta plus sine squared theta equals 1 squared. But 1 squared is just 1. So cosine squared theta plus sine squared theta equals 1. So that's what we have here. This is just 1. So we have 1, and we know that secant x is just 1 over cosine x. So here we'll be left with 1 over cosine x. And when we divide by a fraction like this, we flip it and multiply. So what I mean by that is we'll do 1 times cosine x over 1, and that's just going to equal cosine x. So the final answer for the simplified version is cosine x. Okay, here we have tangent x divided by secant x. So tangent is equal to sine over cosine, and secant is equal to 1 over cosine. So what we have is sine over cosine over 1 over cosine x. And we do the same thing where we flip the bottom and multiply. And then what we'll have is these cancel, and we'll be left with sine x. Okay, so here we're going to simplify and state the domain of 1 over cotangent x and tangent x. So cotangent x is equal to, instead of sine over cosine, it's cosine over sine. And tangent x is equal to sine over cosine. So what we have here is 1 over cosine x over sine x plus sine x over cosine x. Okay, then when we combine the denominators so that we can add them, it will look like this. We'll have 1 over this one here, we're going to multiply by cosine x over cosine x to get the same denominator. And this one will multiply by sine x over sine x to get the same numerator. So here we'll have 1 over cosine squared x plus sine squared x over sine x cosine x. And this again looks like this is going to be 1. So, and we'll have to flip again and multiply. So what we're going to be left with is 1 times sine x cosine x over 1, which is just going to be sine x cosine x. Okay, then for our domain, what we need to figure out is where sine x equals 0 and cosine x equals 0. And we know that sine is going to be equal to 0 at pi, or any n pi, 2 pi, 3 pi, 4 pi, 5 pi, any pi. So x cannot equal n pi. And cosine x will be equal to 0 at pi over 2. So cannot equal n pi over 2. Okay. Now what we have for the next one, we have solve for x, 0 to 2 pi sine 2x. So the way that this is going to look is, where does sine of 2x equal 0? And so if we put 0 in here, sine of 0, this is 0. Sine of 0 is 0 because our y-coordinate is 0 at 0. So sine of 0 equals 0. Sine, and this is x, equals 0. If we try pi, we know that sine of 2 pi will also be 0. And the thing is that where is sine going to be 0? It's going to be 0 at 0, it'll be 0 at pi, at 2 pi, and back around. It will only be 0 here and here because it's our y-coordinate. But we're only going from 0 to 2 pi. So if we say x equals 2 pi, sine of 4 pi also equals 0. So solve for x. If x equals if x equals, we're basically going to need to divide these by 2 in here. If x equals 0, if it equals pi, or if it equals if it equals pi over 2, okay, so then we can still continue for basically everything that puts us back to either this spot or this spot for x. And so that's going to be 0, pi over 2, pi. It will also be 3 pi over 2, and it will also be x equals 2 pi. And those are all the points. If it's 3 pi over 2, then inside here, we'll just be left with 3 pi. And 3 pi would be the same thing as coming back around to pi here. This could be 3 pi. And then if it's 2 pi, it would be 4 pi, which would be the same thing as coming back around here to 4 pi. So those are the final answers there. Okay, so now we're going to do number 5, and it's 2 sine x minus the square root of 3 equals 0. So we're going to just solve for sine x, and we'll add over the square root of 3. And we'll divide by 2. Okay, so that's what we did to bring that stuff onto that side. So now we're left with sine x is equal to root 3 over 2. And this is where we need to bring in the unit circle here. And we need to find out where does sine x, which, if you remember, sine is our y coordinate, but where does it equal to root 3 over 2? And it's right here. It's right here. These are negative. So it looks like it's going to be at pi over 3. Pi over 3 and two pi over 3. And this is going to be our answer using the unit circle. Okay, our next question is number 6. Tangent squared x equals 3. And we're going to solve for x again. So tangent squared x equals 3. Tangent x equals plus or minus the square root of 3. So where does tangent equal the square root of 3? Again, we have to use the unit circle, and we need to think about sine over cosine. So tangent is equal to sine over cosine x. Okay, so we're going to take this one and divide it by this one. So basically, anywhere that we can get a root 3 on the top, so it means that sine is going to have to be with the root 3. So here, if we had the square root of 3 over 2 divided by 1/2, the 2's are going to cancel, and we'll be left with root 3. So that's going to be x equals pi over 3, 2 pi over 3, because it's plus or minus also, so it doesn't matter if this is a negative in the denominator. 4 pi over 3, and 5 pi over 3. Any others? No. Okay, so there's our answer. Alright, the next question is an application question. A ladder leans against a wall, forming a 65-degree angle with the ground. The ladder is 15 feet long. How high up the wall does it reach? So let's do like this. This is 60 degrees. The ladder here is 15 feet in length. So we want to know this height here that it's touching up here. So how can we do that? We can do sine of 60 degrees. Why sine? Because opposite over hypotenuse. Opposite, hypotenuse. Sine of x over 15. And here we can just multiply 15 sine 60 degrees equals x. And if we put that into the calculator, we will get that the height is 13.6 feet. So a ladder is 15 feet long, but over here, it reaches up a height of 13.6 feet on the wall. This is the wall. Okay, another problem, number 8. There's a triangle. The angle is 40 degrees. The opposite side is 8 meters. The adjacent side is 6 meters, 40 degrees, and we want to find the hypotenuse. So what we can do is we can use cosine. Cosine 40 degrees equals 6 meters divided by the hypotenuse, adjacent over hypotenuse. And then from there, what we do is we solve for h. So h equals 6 divided by cosine 40 degrees, and that will equal 7.83 meters. So this one is 7.83. That's all the problems.